moving on, I'll just carry down the y because I don't want to be caught off guard. So inverse tangent. Now here comes the fun of simplifying. In the bottom we have square root of, we have e minus pzc times e plus pzc, which is basically what we have is a plus b, or a minus b times a plus b, which we're very familiar with a squared minus b squared, so I will just continue with that idea and write down e squared minus pz squared c squared. Now you might be already thinking that looks very familiar, but we will talk about that later. But for now, let me just simplify it here. Minus e minus pzc. The square roots are gone because I am multiplying the denominator with the numerator and the numerator, like this denominator with this numerator. Okay, similar thing at the bottom here. E squared minus pz squared c squared, and here we have e plus pzc minus e minus pzc. Now we can see that this cancels out, which is nice. So we have y equal to inverse tangent of, more things cancel out. This cancels out with this, and this cancels out with this. So many simplifications. So we have 2pzc divided by, did I do that right? There's a plus here. That's embarrassing. So let's backtrack. Here's the plus here, which I forgot to carry down. So in this case, these two cancel out. Going back, so we have 2pzc divided by 2e. So this y is essentially y is equal to inverse tangent of pzc divided by e. So this is another expression for the same rapidity which we had seen a few minutes ago as here. We have that entire 1/2 natural log term, and we still have the same expression. We still have pzc. Nothing changed. We still have e. It's just we have it in terms of hyperbolic, inverse tangent hyperbolic expression function. So it's nice. It's another way, and we will utilize the same strategy when we try to show that the rapidity is going to be invariant along the z-axis. Now, in order to show that, we will have to use these 4 displacement or 4 momentum components here under the Lorentz boost. So bringing that down, let's go back to what expression we had. What color should I use? Oh, it's orange. That's a nice color. So let's write down the expression for y. Y is equal, or the rapidity y is equal to 1/2 natural log of e minus or e plus, I still don't know. That is not nice. Or e plus pzc divided by e minus pzc. So we want to find an expression for y prime and show that y prime is essentially the same as y after we apply the Lorentz boosts in this function. So let's just write this down with the square root e plus pzc e minus pzc. So y prime, when we apply the Lorentz boost, we want to apply the Lorentz boost to e divided by c and pz. So one way we can write this rapidity in a friendlier way is we can divide both the numerator and denominator with c by c, and you'll see what that does. Natural log of square root of, we have e divided by c plus pz. Similarly, e divided by c minus pz. So all we did is divide the top and bottom by c. So now we're gonna go back to the y prime, and I'll use this coral color. Y prime is equal to natural log of square root of, now we need to look at the e divided by c function here. So e divided by c prime will be gamma times e divided by c minus, let me just copy this, which will make life much easier. Let me just keep it here. So we have gamma times e minus c beta pz. That is just the e divided by c term here. And then we have the pz. Or pz prime. Pz prime is gamma times pz minus beta e divided by c. And same thing continues in the bottom with the minus sign. Now one other thing that we can do is get rid of these gammas. We don't need these here. I'm getting rid of the gammas. Actually, let me use a different color because I can barely see. Oh, let's use this teal color. Gamma gets cancelled out. So we're left with natural log of square root of e divided by c minus beta pz plus pz minus beta e divided by c. Similarly in the bottom, e divided by c minus beta pz minus pz plus beta e divided by c. Now we will have to simplify, and one way we can simplify, or we will try to regroup here, and let me highlight the terms that we are going to regroup. We see EC here, we see EC here, E divided by C here, E divided by C here. And the other group is, I'll highlight it with yellow. No, don't like that. Blue. Here we see abundant of PZ, PZ. So we will regroup it like that. So natural log of square root of, I'm factoring E divided by C out first, 1 minus beta. And then PZ, 1 minus beta. So I am first taking out of here, then here. similarly at the bottom, E divided by C, we have 1 plus beta. This one is just addition, it's a subtraction. And then taking out PC again, we have first taking out of here, then here. It's just slightly, it's just one over the other. It's the same thing. We have 1 plus beta. Now, we're rolling with the factorized